Okay, so number one, we are factoring. To me, this looks like there's a common factor of x, so I'm going to pull that out. When I pull the x out of this guy, I'm sort of writing whatever's left over inside parentheses. If I remove x from x squared, I'm left with an x. And if I remove x from 5x, I'm left with a 5. Cool, so that's number one. Number two, I think it's a similar situation. There's just a common factor which can be removed. In this case, if we look at the coefficients 18 and 6, 6 divides both of those, so we can factor out a 6. And we can also pull out a common factor of x from both of those. So the greatest common factor that I can remove is 6x. So if I pull 6x out of 18x squared, that's going to leave me with 3x. And if I pull 6x out of itself, I actually am left with something. I'm left with 1. 3. First of all, I noticed that there is a common factor between all three of these terms. There's if I look at the coefficients, 3 divides all three of those coefficients, 6, 9, and 12. So I'm going to pull out a 3. Also, there's an x in all three terms, so I'm going to factor out an x, and we'll see what's left over. That's going to leave me with 2x squared minus 3x plus 4. Is that right? 6x cubed negative 9x squared 12x. Yeah, I think that's right. Cool. Now, in this case, I think we can go a little further because this guy right here can probably be factored. Maybe. Yeah, so you probably have different methods for factoring guys like this. Maybe you guess and check, and like you draw a box. That's totally fine. I'm not going to draw a box because I don't like guessing. What I'm looking for is a pair of numbers that multiply to the product of this number and this number, so 2 and 4. So I'm looking for a pair of numbers that multiply to 8 and which add up to negative 3. I don't think there is any such number. I don't think that this factors, actually. I don't think that this quadratic factors. Like if we look at the solutions down in number 3, yeah, this doesn't factor, so that's not reducible. Cool. Okay, so I guess that's all that we can do. Great, so that's number 3. Number 4. Number 4 is a difference of 2 squares. Notice that both of these terms are perfect squares, like 9 is a perfect square, y squared is a perfect square, 25, that's a perfect square, and it's being subtracted. That's a difference of 2 squares. So the general idea behind these is that a squared minus b squared is equal to a plus b times a minus b. That's how you want to think of a difference of 2 squares. So in this case, that's going to be 3y minus 5x times 3y plus 5x. It's essentially like the square root of the first term minus the square root of this term times the square root of this term plus the square root of this term. And that's all we can do there. Number 5, I think there's a common factor of negative 2x. And if I factor that out, that'll leave me with x plus 4. Cool. Number 6. So this is a quadratic trinomial. You can do the box method if you want. What I would say is whenever the lead coefficient is 1, all you need to do is find a pair of numbers that multiply to this guy and add up to this guy. That would be 6 and 1. So this thing factors as x plus 6 times x plus 1. Number 7, there's a common factor which I can remove, which is 2. So if I pull 2 out of that, I'm left with x squared plus 8x plus 12. And then probably that quadratic can be factored. The lead coefficient is now 1. So I'm just looking for a pair of numbers that multiply to 12 and add up to 8. I think that's 6 and 2. So this factors as x plus 6 times x plus 2. Number 8. That is actually a difference of 2 squares, surprisingly. I know it might not look like a difference of two squares because the exponents aren't squares, but for something to be a difference of squares, it just has to be one thing squared minus something else squared. 81x to the fourth actually is something squared. 81x to the fourth is, in fact, quantity 9x squared all squared. Do you see what I'm saying there? So that actually is a perfect square. And likewise, y to the sixth is, in fact, something squared. Y to the sixth is actually y cubed, quantity squared. So that is a difference of two squares, so we can factor it as such. So it's going to be the square root of the first term, which is 9x squared, minus the square root of the second term, so that's y cubed, times the same thing but with a plus. Okay, so that's how that guy factors. And then I think that that's all that we can do on this. Okay, cool. Number 9. Number 9 is also a difference of two squares. It's going to be 5x minus 4 times 5x plus 4. Yeah, sweet. Number 10. That is a trinomial. There's no common factor to remove, and unfortunately the lead coefficient is not 1. So how do you factor things like this? You might draw a box, you might sort of guess and check. You can do whatever you want. I don't like guessing in math, so I'm just going to do this in a way which is guaranteed to work. But you maybe haven't seen it before. It's called splitting the middle. Sometimes people teach this, sometimes they don't. I'm going to look for, so first of all, I'm going to look at the product of the first and the last terms. So 8 times 3, that's 24. So I'm going to look for a pair of numbers which multiply to 24 and which add up to this middle term 10. So a pair of numbers which multiply to 24 and add up to 10. So I think that's 4 and 6, right? 4 and 6 multiply to 24 and add up to 10. So what I'm going to do with that is I'm going to split the middle, in other words, the middle term. So my two numbers are 4 and 6. So I'm going to rewrite 10x as 4x plus 6x. All right. Then I'm going to basically group these two terms here and pull out the greatest common factor between just those two terms. The greatest common factor between those two terms is 4x. And if I remove it from those first two terms, I'm left with x plus 1. And then likewise, I group the second two terms and I pull out the greatest common factor there, which is 3, which leaves me with, again, x plus 1. And now notice that you have two terms here, both of which contain the common factor, x plus 1. So x plus 1 is actually a factor which can be removed, and that leaves me with 4x plus 3. So this method, avoids guessing and checking, which I prefer, although it's not exactly short either. So do whatever you want, but that's my method. 11 is exactly the same as number 10. It's a trinomial. There are no common factors to remove, and the lead coefficient, unfortunately, isn't 1. So just like number 10, I'm going to do it the same way. I'm going to split the middle. I look at the product of the first and last numbers, that's 6. And I'm going to look for a pair of numbers which multiply to 6, but which add up to the middle number, negative 5. So what pair of numbers multiplies to 6 but adds up to negative 5? I guess that would be negative 2 and negative 3 multiply to 6 and add up to negative 5, so negative 2 and negative 3. So what I'm going to do is I'm going to split the middle. I'm going to rewrite that negative 5 as minus 2x minus 3x. Okay. Then just like before, I'm going to group these two terms. I'm going to view those two terms as being one group, and I'm going to pull the GCF out of those two terms. The GCF of those two terms is 2x. When I pull it out, I'm left with x minus 1. And then likewise, I'm going to look at these two terms and pull out the GCF. This is kind of tricky because you might be inclined to say that the GCF is just 3. However, if you do pull out a 3, then you're left with a minus x plus 1. For this procedure to work, you want this thing in parentheses to be the same as this thing in parentheses, and they're not quite the same. One is x minus 1, the other one is negative x plus 1. The trick is to actually, instead of factoring out 3, factor out minus 3. If I factor out minus 3, then I'm left with x plus 1, or sorry, x minus 1, excuse me, x minus 1. And the idea there is now I have a common factor of x minus 1 in both of these terms, which can then be factored out. So that's x minus 1 quantity 2x minus 3. As I said for number 10, like, you know, if you guess and check or box method your way through this, whatever you want to do, I'm not going to throw too much shade on those methods, but I do like doing problems without having to guess. Number 12, first of all, there's a common factor, like a coefficient that we can remove of, I think just 2, right? I think 2 is all we can do. So pulling out a 2, that leaves me with 25x squared minus 4y to the 8th. And then what I notice is that this guy is a difference of 2 squares. So that's going to factor as, you know, the square root of the first term, which is 5x, minus the square root of the second term, which is 2y to the 4th, times the square root of the first term plus the square root of the second term. Cool, cool. Okay, so we are done with those. Now we're moving on to, hidden quadratics. Spooky. So we're looking for hidden quadratics. Yeah, there's a variety of ways of doing this. X to the 4th minus 10x squared plus 21. If you prefer to do this method of like making a substitution, like choosing u to be equal to whatever, you would choose u to be equal to x squared. The reason for that is if you decide to choose u to be x squared, then u squared would be x to the 4th. And what that means is the original expression that we have here can be rewritten in terms of u. You have x to the 4th, but that's just u squared, minus 10x squared, but that's just minus 10u plus 21. And now this expression is like literally a quadratic, right? Not just a quadratic in structure, but literally a quadratic. And so we can factor it in the usual way of, you know, it's 3 terms where the lead coefficient's 1. I'm going to look for a pair of numbers that multiply to 21 and add up to negative 10. That's negative 3 and negative 7. So this factors as u minus 7 times u minus 3. Now, of course, I don't care about u, the letter u, not y-o-u. I don't care about u, I care about x. So I should switch back to x. And what is u, or what are u? It's x squared. So that's x squared minus 7 times x squared minus 3. I don't think these can be factored any further because neither of these are, 3 and 7 are not squares. You could factor this, I guess. Like, I don't know if they want us to. Like, you could factor this further. You could be like, oh, 7 is a perfect square. It's the square of root 7. Like, you could do that. I don't know if they want us to. You know, you could like play some games like this. I don't know if they care, but yeah, you could do that. 14, very similar. Make the substitution u equals x squared. You know, how do I know it's u equals x squared? Well, you know, basically, this thing is a quadratic structurally. Like, it has quadratic structure. And basically what that means is that this guy here is the square of this guy here. Like, if you square x squared, you get x to the 4th. That's true for all of these. Like this one here, if you square x cubed, you get x to the 6th. Right here, if you square x cubed, you get x to the 6th. It's like quadratic structure or quadratics in disguise. It's all about like the highest power term being the square of like the other one. That's kind of the clue that you're looking at one of these things. And you should just make u equal to like whatever this guy is right here. In this case, x squared. So if I choose u to be x squared, then u squared is x to the 4th, which means I can convert this guy from x's to u's. So x to the 4th is really just u squared minus 7x squared. That's just 7u plus 12. And then I can factor this thing as usual. I'm looking for a pair of numbers that multiply to 12. Again, this is a quadratic with a lead coefficient of 1, so I just need a pair of numbers that multiply to 12 and add up to 7, or negative 7. So that's negative 4 and negative 3, so like u minus 4, u minus 3. But then I have to remember I don't care about u, the letter u. I care about x, so I should switch back. So I get x squared minus 4, and then x squared minus 3. The first factor definitely can be factored. It's a difference of 2 squares. That's, you know, x minus 2 times x plus 2. Do we want to factor that other one? Yeah, why not? Like, I don't know, you kind of have to force it because 3 isn't like really a perfect square. You know what I mean? Like, it's it's the square of square root of 3. So you could factor it that way if you wanted. I don't know if they want us to. I'm just going to do it. It's too late now. Number 15, yeah, like, again, quadratic in disguise, right? Like this thing, x to the 6th is the square of x to the 3rd. This time I'm going to choose u to be equal to, as always, it's just this guy right here. So like choose u to be x cubed. If u is defined to be x cubed, then u squared would be x to the 6th, and therefore this expression 2x to the 6th, that's really just 2u squared, and then plus 7x cubed, that's just 7u minus 15. Now this is literally a quadratic. I can factor it as we usually do. How do you factor this? Like I've said before, you can guess and check your way through it, whatever. I'm going to use the method of splitting the middle because the lead coefficient isn't 1, so like it's sort of annoying. So what I do is I look at the product of these two numbers. 2 times negative 15, that's negative 30. So I want a pair of numbers that multiply to negative 30, and I want the two numbers to add to this middle number, 7. So like what numbers do that? I think 10 and negative 3. 10 and negative 3 multiply to negative 30, and they add up to 7. So 10 and negative 3, I'm going to use those numbers to split the middle. In other words, I'm going to rewrite 7u as 10u minus 3u minus 15. And then, like the other problems, I'm going to group these first two terms as a group and pull out the GCF. There's a common factor of 2u. When I remove 2u from this term, I'm left with a u. And when I remove 2u from this guy, I'm left with a 5. And then likewise, this guy here, yeah, there's a common factor of 3. You really want to pull out a negative 3, though, because if you pull out a negative 3, you'll be left with positive u plus positive 5. And for this procedure to work, you want this factor here to be the same as this factor here. Like you want u plus 5 to appear in both. So you need to pull out a minus 3 to make that happen. Otherwise, like this factor in parentheses would be like a negative u minus 5 or something, and you wouldn't have a common factor. Anyway, so now there's a common factor of u plus 5. So I'll pull that out. When I pull u plus 5 out of this first term, I'm left with 2u. And when I pull u plus 5 out of this second term, I'm left with minus 3. Then I just need to switch back to the x's. What is u, or who are you? It's x cubed plus 5. And then 2u minus 3, that's 2x cubed minus 3. I don't think we can factor that any further. Cool. Number 16. Yeah, so number 16, looking at this guy, again, I would choose u to be equal to x to the 3rd, which means that u squared is going to be x to the 6th. So our expression becomes u squared minus 7u minus 8. Cool, this has a lead coefficient of 1, so I'm just looking for a pair of numbers that multiply to negative 8 and add up to negative 7. So that's negative 8 and 1, right? So u minus 8 times u plus 1. Cool. Then I need to switch back to x's, so that's x cubed minus 8 times x cubed plus 1. If you got this far, that's fine. Like, that's good enough. You don't have to go any further than this. You may have studied last year difference of 2 cubes and a sum of 2 cubes. You don't need to know that for this course, so like it's totally fine. But if you wanted to factor this further using like the difference of 2 cubes formula and sum of 2 cubes formula, you could. Off the top of my head, I have to think about what it is. I'm pretty sure it's x minus 2 times x squared. Is it minus 2? No, I think it's plus 2x plus 4, I think is how that factors. The first one? I don't know. It doesn't matter. Like, who cares? That's a formula that, like, if I don't remember it off the top of my head, you don't need to know it either. Number 17. Okay, what are we doing here? We are doing... what are we doing? What are the instructions? Oh, simplify. Yeah, so basically just distribute and then combine like terms. So if I distribute this negative 3x to the two terms in parentheses, I'm going to get minus 6x squared minus 24x. And then I look for like terms to combine. Like terms just means same variables, same exponent. So there's only one x squared term, this guy right here, so I'll just write that. That's the only x squared term. But there are a couple of like plain old x terms, this guy and this guy, so I can combine those. 7x minus 24x, what is that, negative 17. Negative 17x. And then there's just one constant term, right, of negative 6. So yeah, I think that looks right to me. Cool, cool. Number 18, we're doing the same thing. We're just going to start by distributing. What am I distributing? This minus sign. I'm just going to distribute that minus sign to get negative 3x plus 5 plus 2x squared. Then I'm going to look for like terms, which means same variable, same exponent. I see 7x squared and 2x squared, that's 9x squared. I see negative 8x minus 3x, that's minus 11x, and then I see a plus 5. Cool. Am I supposed to factor this? Probably not. That's fine. Okay, what are we doing now? We are doing rational expression stuff. So, what are we doing? Are we simplifying? I guess we're just simplifying. Yeah, there aren't any instructions, but I'm pretty sure it's just like simplify this and make it as nice as you possibly can. Yeah, the name of the game here is, you know. So this expression here, we just have this rational expression, x squared minus 25 over x squared plus 5x. The name of the game is to just like, factor and then cancel common factors if there are any, which like there typically are. So the top is a difference of two squares. It factors like this. The bottom, there's a common factor of x, which can be removed, and we get this. Then you cancel the common factor of x plus 5 on the top and the bottom, and you're left with x minus 5 over x. So that's that. 20, we have x squared minus 5x plus 6 over x plus 4 times 3x plus 12 over x minus 2. You should probably factor all this stuff before you carry out the multiplication. Like if you just carried out the multiplication, you would have to multiply this numerator with that numerator, and like that would take a while. Like that would be like you'd have to FOIL it all out. There'd be a lot of terms. It would be kind of a nightmare. I think if we factor it, if we factor everything, my suspicion is we're going to be able to like cancel some common factors before we do that multiplication, and our lives will be easier. So that first expression, the x squared minus 5x plus 6, that can be factored as x minus 2 times x minus 3. And then in the second fraction, the numerator has a common factor of 3 that I can remove like that. Are there any common factors? Yeah, there sure are. I mean, if you like, you can carry out the multiplication before canceling common factors. You're just multiplying across the top of the two fractions, so it's the two numerators multiplied. I'd prefer to put the 3 first because it's a coefficient. You have an x minus 2, x minus 3, and then x plus 4. And then in the bottom, we have x plus 4 times x minus 2. And then as you can see, you've got some common factors of x minus 4 here, and then you've got an x minus 2 here and here. You could kind of cancel those factors like at this stage before you even multiply, but whatever, it's fine. So what are we actually left with? We've got the 3 and the x minus 3 and then just x minus 2. No, the x minus 2 is canceled. We're left with, oh, just 3 times x minus 3, right? Nothing else. Yeah. Yeah, cool, okay. 21, I'm gonna make a new page here. Okay, so 21, my God, look at this. I mean, aren't you just so thrilled when you see a problem like this? The division symbol, ridiculous. I don't even know yeah, I guess that's the notation for division. Yeah, the division symbol is kind of grotesque. Like, I don't know. Okay, did I copy this right? Blah, blah, blah. Yeah, I did. Cool. Yeah, so how do you divide stuff like this? Well, you know, you're basically just dividing... you're dividing fractions, and dividing by a fraction means you're just going to multiply by the reciprocal. So I'm going to do a couple of things. First of all, I'm noticing that I can pull out a common factor of 3 in that numerator. I don't know if that's going to matter, but like I might as well. And then as far as the division by this guy, as I say, that's the same thing as like multiplying by the reciprocal. So it's basically keep it, change it, flip it. Like keep this guy, change this to multiplication, flip this guy upside down. 15x squared minus 7x minus 2 over 6 minus 13x plus 6x squared. A couple of things to say about this. Like, before you carry out the multiplication, just like in the previous problem, you should really factor everything that you can. My guess is that probably some of these guys factor. The bottom denominator here is kind of written in a stupid fashion, like the squared term is last. Let me just rewrite that so it's done correctly. It's 6x squared minus 13x plus 6. And now I'm going to try and factor the top and the bottom of this guy, and hopefully some like common factors will appear and I'll be able to cancel stuff. So in the numerator, oh my god, what a pain this problem is. In the numerator, the lead coefficient is not 1, so I need to. You can do the box method, do whatever you want. I like to split the middle, which means I look at a pair. I look at the product of the first and last numbers, which is 30. I want a pair of numbers that multiply to 30 and add up to -7. So that's -10 and 3. So I'm going to rewrite that middle as minus 10x plus 3x, and then I have the minus 2. I'm also going to do the same procedure to the bottom, so I'm just going to work both of these polynomials like at the same time in each line. Okay, so I'm looking for a pair of numbers that multiply to the product of this guy and this guy, but which add up to this guy. So 6 times 6 is 36, so I want a pair of numbers that multiply to 36 and which add up to -13. So I think that's -9 and -4. So I'm going to split that middle term as -9x minus 4x, and then I have plus 6. Cool. Great. The next line, I have So as usual, I'm going to like pull out the GCF from these two guys. So the GCF there is 5x. That leaves me with 3x and then minus 2. And I'll pull out the GCF from these two guys. There actually is no GCF, so the GCF is 1. Like you can always pull out a 1. Plus 1 times 3x minus 2. And then I'm doing the same thing in the bottom. So these two guys here, the GCF is 3x. So I'll remove that, which leaves me with 2x minus 3. And then these two guys here, the GCF is just 2, but I think I want to pull out a -2 to make the same factor of 2x minus 3 appear in both terms. So, cool. All right, so now, all right, so what's happening now? So now, stop. So now I have a common factor in this numerator, and in these two terms, I have a common factor of 3x minus 2, so I'll pull that out. And I'm left with 5x plus 1. And then in that bottom denominator guy, I have a common factor of 2x minus 3. So I'll pull that out, and that leaves me with 3x minus 2. Cool. Yeah, so there's definitely a lot of cancellation, right? Like this 2x minus 3 gets killed by that 2x minus 3. This 3x minus 2 cancels with that 3x minus 2. Oh my god. And this 5x plus 1 cancels with this 5x plus 1. Would you look at that? I mean, yeah, it's amazing. So I think the only thing that's left is 3. So all that work just to figure out that this stupid thing was 3 is kind of an annoying problem, but what you gonna do?